Alright, this is lesson 1.3, measuring segments. In this lesson you'll be able to find and compare the measures of line segments. And you're going to use some of the stuff you learned in the previous lesson, so make sure you've watched those videos as well. Alright, we're going to start off with a couple of definitions. The first one is congruent, and it just means that figures that have equal measures are congruent. Now we'll talk more in a second, but the symbol for congruent looks like this. It's an equal sign with a squiggly over the top. Next is midpoint, and it's exactly how it sounds. Midpoint is the point in the middle. It's a point that divides any figure into two equal segments. So for this picture, this line segment is split in half by this point in the middle. That's the midpoint. A bisector is a line, segment, ray, or plane that intersects a figure, a segment, or angle at its midpoint. So this red line intersects this line on this triangle right at the midpoint. So this line is a bisector. Vertex, you might remember vertex from angles, but in this definition it's where two endpoints of two rays intersect. So when you're making an angle, remember that a ray is a point and then it goes on forever in one direction. These two rays share an endpoint. That's the vertex. Alright, we've been looking at postulates. We're going to add one more, and that's postulate 1.6, and it's the segment addition postulate. And it's pretty common sense, like most of the other postulates. It just says that if you have 3 points, A, B, and C, and they are collinear, which means they're all on the same line, A, B, and C, and if B is in the middle, or in between A and C, then A, B, this segment, plus B, C, this segment, equals AC. Pretty easy. That's the segment addition postulate. So, we're going to look at some line segments on a number line. Now, you might be going, well, I can just count from S to T to figure out what ST is. But the goal is to get you to develop some skills that will be transferable to other problems that aren't as easy as just counting. So for this problem, to figure out the length of ST, we're going to use what we know about finding the distance. And that is, to find the distance between S and T, you just subtract the points on the line. So to find ST, I'm going to subtract -4, which is where S is, minus 8, which is where T is, and that's equal to -12. Now, you also know that the length, or the distance between 2 points, doesn't have a direction, so it's not positive or negative. So to find the distance, you always take the absolute value. So the absolute value of -12 is 12. That means the length, or the measurement of ST, is 12. You can do the same thing with other lengths on that number line. So for example, to find UV, we're going to find the distance between point U and point V by subtracting and taking the absolute value. So 10 minus 14, absolute value of that. Absolute value of -4 is 4, so UV equals 4. One more time, SV. To find SV, we take the absolute value of the difference of those points. S is -4, minus V is 14. -4 minus 14 is -18. And the absolute value of that is 18, so SV is 18. Okay, now here's where the definition we spoke of earlier, congruent, comes in. When numerical expressions have the same value, you would say that they're equal. But if two segments have the same length, then you don't say the segments themselves are equal, you say the segments are congruent. So it means almost the same thing, it's just slightly different. So in this picture, A, B, and CD are both 1 inch, so you say the measurement of those two segments is equal, but you would say the actual segment itself, A, B, and CD, are congruent. And you can mark these in a way to show that they're congruent just by putting a hash mark. So one single hash mark on AB and one single hash mark on CD means these two segments are congruent. And you'll get used to using those marks as we get further into geometry. Okay, so if we look at this number line and we are asked if AC and BD are congruent, what we really want to know is the length of AC equal to the length of BD? Notice when I'm asking about congruency, I use the segment mark at the top of these two. When I'm asking if they're equal, I don't put anything over the top. So to figure out if AC and BD are congruent, we have to first figure out how long is AC and how long is BD and see if they're equal. So AC, like we did in the previous problem, to find the length of AC, I would subtract -2 minus wherever C is, and it's between 4 and 6, so that's 5. -2 minus -5 is -7. Absolute value of that, so AC equals -7. BD, B is at 3 minus D is at 10. That's -7, so the absolute value of -7 is 7. BD equals 7 because, oops, did I say -7? I meant 7. Because AC and BD have the same length, then you can say the segment AC is congruent to the segment BD. So to answer the question, yes they are. Alright, again at the beginning of this video we talked about midpoint and bisector. So the midpoint of a segment is a point that divides the segment into two congruent segments. So B in this figure is a point that cuts AC into two congruent or two equal segments. A point, a line, array, or other segment that intersects a segment at its midpoint is said to bisect that. So this line bisects it. That's called a segment bisector. They're similar. The midpoint is the point in the middle. The line is the thing that cuts it in half. It's called a segment bisector. Okay, last example. In this figure, Q is the midpoint. Q is the midpoint of PR. If Q is the midpoint of PR, then you know that it cuts this whole segment PR into two equal segments. So your job is to figure out what's PQ, what's QR, and what's the whole thing. Well, in this problem you're going to use a little algebra because PQ is equal to this expression 6x minus 7. QR is equal to this expression 5x plus 1. So you just have to set them equal and solve. 6x minus 7 equals 5x plus 1. To solve this algebraically, you subtract 5x from both sides, and you get x minus 7 equals 1. Then you add 7 to both sides, and you get x equals 8. So you figured out what x is, but you haven't figured out what PQ, QR, and PR are. So to do that, you take this value and put it in place of the x in the expression. So PQ is going to be equal to 6 times 8, which is 48, minus 7, which is 41. To figure out what QR is, you could put 8 in place of x, but you already know that QR is going to be the same length as PQ, so QR is also 41, and that means the whole thing would be 41 plus 41, or 82. And that's it. So that's how you find line segments, measurements, and figure out the length of each segment using algebra.